All right, so we're going to talk about functions. We're going to give this recording take 2, see how that goes. So we talked a little bit about several things. So just for FYI, I am going to turn on project 1 probably this afternoon or tomorrow, definitely before the weekend. We're not officially starting it till the second day of class next week because we're going to do assignments for in class and try to get everybody get the short week caught up. So I will be putting it out on over the weekend for those of you that want to look at it and get started. It's fine, I don't care. Get ahead of me. That's my life. Perfectly happy. It will be broken into 3 parts. I will grade each part independently. That being said, do not move to part 2 if you have not completed part 1, because it won't work without part 1. They build on each other. So part 1, if I'm remembering correctly, and the numbers may be slightly off, like 74 points of the grade out of 100. So if you get all of part 1 working, you should have a C or higher, right? If you get part 2 working, there's some additional points there. Part 3 is like the last 10 or so points, I think. Don't hold me to those numbers because I do a lot of assignments. But I do always try to fix it with part 1 when you go passing grade. Because part 1 is absolutely the easiest part. It should mirror a lot of the stuff that we have done in our labs and assignments. Question. It's not going to be due until a week from the day. So that weekend. You'll have a whole week of class that we're going to work on it. That doesn't mean that I'm going to give you the code. It means it's going to be me answering questions and me doing pretty much like what we do on Fridays in here on labs. Is I'll be able to do answer questions. If everybody hits the same snag, we'll go over it. And I'll record the conversations probably in class both days to make sure that the online students benefit from that help also. All right. The directions will tell you that you can only get help from the CSX lab and the instructors. That's outside of class. You cannot go to your classmate's dorm room and copy their code. That's a no-no. You can, however, while we're in class and in lab, talk to your neighbors about, hey, I think I have an error here. Did you see it? That sort of thing. You can look at your neighbor and say, oh, you know, I use a loop there. Things like that are perfectly okay. Do not show them and let them copy your loop. That is not okay. Does that make sense to everybody? Because we want you to be helpful, but we don't want you to do it for them. Part 3, the directions say you can only ask me for help. I'm probably will change that or put the CSX people in there too, because there's a lot of you guys. Everybody getting time with me might be hard. So I will change that direction before I put it out there, because there's a lot of you and there's a lot of online students too. So part 3 is the hardest part, but you can still do really well on the project without ever attempting part 3. Last week, we talked about the standard library. We talked about turtles and how to create one and draw with them. We talk about loops, specifically for loops with ranges. We talked about the drive principle because we don't want to repeat yourself. We talked about refactoring code and making it more streamlined and reusable. And we talked about the accumulator pattern, which is just a special for loop where it adds things up, right? So all these things are going to come into play again as we move forward. Nothing you learned in previous weeks will ever be forgotten because this class definitely builds on itself. Everything you learned last week will probably be applied this week too. So this is usually where somebody says, are we going to have a cumulative final? Yes and no. You're going to have an exam at the end, which will be the last exam from the book and the reading. Is it cumulative of all the material you learned? Yeah, because you can't do Python any other way. So it's not going to be any different format. It's not going to be any worth any more points than a normal exam, but it will have stuff throughout the entire semester. So this is an example of the accumulator pattern. We asked the user how many numbers they want to input, or how many numbers they want to add up together. We create some variables to hold that number and the total or the sum. And then we use a for loop to have them enter and then add them together. So you can actually have the input statements inside the for loop. We did this in the assignment 3, if I remember correctly, right? Because you had to ask it on day 1, day 2, day 3 about the temperatures.
Yes, I have a question.
Have a question about that?
About that. So, it's the hardest one for me. Like, I didn't understand how to how to day 1, day 2, day 3.
And I'm almost positive I wrote that line of code for you in class on the Thursday before it was due. Didn't I? Or was that my other class? Did you come Friday? Yeah, did too. All right, I'll be happy to sit down with you one-on-one and show you, but I'm not going to redo it right now. So we are going to, obviously, since I'm bringing up the accumulator pattern, we're probably going to accumulate some numbers this week, right? Yes. So be aware that these slides are available to all of you. They are in your Coursed In class. You can download them, go back to them. You can create your own notebook about them if you want to. You can take your own notes. Amazing. But these are available to you to go back and look at patterns and stuff. I say this because you're going to want to do some of this when you do the project, right? Because the project's where you show me what you know and not what you can repeat or copy when I put it on the board. So we're going to talk about functions and methods. I interchange the words because they're functions usually in Python. They're called methods in Java. So be aware, I'm teaching both right now. I interchange the words, and it's really easy to mix the two together. You can ask my student who has Java and Python at the same time. It's really easy to mix up the syntaxes. So we are going to implement these functions. You've already been using functions. So forward, turn, the left and the right turns, all those things that we do with our turtle are actually functions in the turtle module that somebody else already wrote. So we've been using functions. So now we're going to learn to write our own. So the benefit of a function is that they are reusable. They should do one thing and do it well. So we could write a function with our turtle called draw box, and it should be able to draw a box every time we need one. We only have to write the code to draw that box once, and then we can call our function over and over again. So y'all see the benefits of this, right? We can give functions information, and we can get information back from a function. Functions execute just like your program does, they execute in order. So if you go into a function or you use a function, each of the steps executes in the order that you wrote them. The function happens in your main code in the order that it's written in there. So if you call a function like draw box before you actually define draw box, you're going to get error saying it doesn't know what you're talking about because it hasn't got to that line yet where you created it. So you have to create functions first, then use them. That makes sense? I'll show you this in a minute, but functions from other modules kind of pause your current program, go to that module, run the function code, and then go back to the next line. So it's kind of like as a placeholder, it knows how to get back to it. There are some special functions called constructors that can alter the way your objects work, and we'll talk about that a little more as we get further along. So this is a very simple function called move in box. So we're going with the turtle move in a box shape, right? There's 8 lines of code associated with this function. It's just like your for loops. The lines of code that belong to the function are indented, right? The numbers I just put there just to make this easier. They're just like the line numbers on the side of your screen. Don't, if you're copying this into your idle later, don't put the numbers in there. But once it enters this function, it's going to do all these other function calls in that order. Does that make sense? So functions obviously can call other functions, right? Because this is a function I created, but every line of code in there is called a turtle function. Up, forward, not backwards. When I say I'm calling a function, or sometimes you'll see invoking a function in your textbook, that means that I have an object like my turtle with a period and then the function call. So the turtle needs this function. It's going to invoke it. It's going to make it run. That make so you do have to have generally an object or something for that function to work on. Turtle functions don't work without a turtle. So at some point before I started invoking functions, I have to create a turtle. You know, with the screen and the turtle calls, right? So this is 3 examples of functions. I have draw figure, move dash, turn left with a dash. And I want to show you how the order of this works. So, yeah.
Why do you have def?
Oh, yeah, that's a good question. Because I'm defining the function.
Oh.
And DEF is short for define. So the first line is the definition. And I actually have a slide on that in a couple of slides. I want to reorder the slide deck. I don't think it does it in a very good order. But I'm going to do that one day.
And does def only mean defined in Python, or is it the same for Java?
It's only in Python. Java does it completely different. But welcome to programming languages. They're similar enough that they all build on the same building blocks, but they're different enough to confuse you. All right. So we have 3 functions, right? And draw figure is going to call turtle functions, and then it calls one of the functions we created, which is absolutely legal as long as it's been defined before it's called, and they're all defined. So in this case, it's going to put the pin down. It's going to call this new function. So now it's going to jump down here, and run these lines of code. And then it goes back up here and calls this other function, and it does these lines of code, which calls this function, right? So let's show you that a little bit clearer with some numbers and stuff. Step 1 is put the pin down. Step 2 is move dash. Step 3 is to go into move dash and start executing the lines of code here. So 3, 4, 5, 6 happen and move dash. 7 goes back up to the original function, and that's going to turn left with a dash. So it's going to jump over into the blue function and do 8, 9. Oh wait, it's going to call move dash on 10. So now I'm going back over to the second function and doing 11, 12, 13, 14. 15 puts me back into the turn left function. When that one finishes, it jumps back up to the original function because it all started here, right? So there's basically a pointer or an imaginary bookmark, let's say, that keeps up with where the program started, where the calls came from, and where they need to go back to. Yes, ma'am.
And so we have to write all this out, right?
No,
Okay.
you have to know how this works, and you have to have the functions created, but you do not actually have to keep up with where it is executing at any point in time because the program's going to do that for you. You just have to think through the logic to know it's going to work.
Or
That's
just
it.
pray.
Huh?
Or just pray.
You could pray. That's completely up to you and your belief system. Mostly, I need you guys to see the big picture. That we do this a lot because we have things called helper functions. Like, if we know we need to draw a square and we have this big function that's drawing an overarching picture, which you're going to do for your project, oddly enough, then we need to be able to jump out of our execution, go get the box, make it draw, and then jump back into where we were at. So what I'm trying to show you is that there's a lot of complexity in computer science, but there's also a beauty and an art to how everything flows together. Or at least in my head there is. You may all not think it's as cool as I do. That's fine. But I want you to know that the computer is going to do things in a logical step-by-step fashion. It might be hard to follow in real time, but you can follow it. And again, my old school ways are going to come out. And if you get confused, I'm going to tell you, hey, grab a pencil and a piece of paper and draw yourself a diagram. See how it goes. Flow diagrams are your friend. Promise they are. And, you know. So the function definition looks like this. You have DEF, some name, whatever name you want to give it. I personally think you should name it based on what it does. It'll make your life much easier when you're trying to use a bunch of them in a long string of code to know what they do. I had a high school student years ago who thought it would be fun to turn in their final project and name all of their methods Pokemon characters.
Yes, I remember.
And all of their variables were Pokemon characters. I was super confused because I know who Pikachu is. That's about it. I didn't know there was.
Everybody knows Pikachu.
Well, of course. I didn't know there was over 200 Pokemon characters. Did y'all know there was over 200 Pokemon characters? Okay. Some of you are going, yeah. No.
1,000.
Oh, I'm sure there probably are, but.
Because like, you know, like.
Well, this
there's
was
one different regions.
She's like, don't explain it to me.
No, please don't explain it to me. I have a hard enough time keeping up with the games that my children play now, much less what they played when they were children. And mine never got into Pokemon. They're too busy playing Dungeons and Dragons and World of Warcraft and stuff like that. Anyway, sorry, off track. So you have the definition, DEF, a name, a useful name. Do not give me unuseful names. Actually, you'll find a lot of my specifications tell you exactly what to name the functions. There's a reason for that, because when I go to grade, I'm going and looking for specific pieces. Parameters. The things inside the parentheses are called parameters. They also are referred to as inputs. anything that function needs to run from the user, the program, a file, goes in as a parameter. You can have 0 to many parameters in a function. Every parameter is separated by a comma. So examples of this. Turtle forward takes a number, right? That number is its parameter for how many steps it's going to take. Turn or left or right do not take a parameter because it's just going to make a 90-degree turn. It doesn't need anything. It knows it's turning 90 degrees. There are some turns that take parameters because you don't always want to go 90 degrees. But we'll talk about that later. And then you can have statements that go with your function. You should have at least one, but you could have many. There's no reason to define a function if you're not going to put any statements in it, right? I do know that sometimes people do go through and define functions as placeholders, kind of outline their code, but don't forget to go back and put the body or the statements in when you go to execute it. So this is just another visual of that with some color coding. This was called display information or display info. It has two parameters. It takes a name and a message. What it's going to do is it's going to print out your name on one line and it's going to print out the message on the next line. So the name variable could hold Tracy. It could hold Bob. It can hold Alex. It could hold whatever we make name before it gets passed in. And then the message could be anything. It could be a hello message. It could be a paragraph worth of stuff. It doesn't matter. Whatever's stored in that variable is what's going to be printed. Just like we did before with print statements. So, same slide. Anyway, you can hard code information in when you pass in to a function. So instead of giving it a variable name, you could just give it a string that says Bob. I don't recommend it because that doesn't make it reusable and friendly, but you can absolutely do it. So in this case, hard coding in Bob and good day. So the two print lines would be hi Bob, and then it would say good day on the next line. Some functions return things. If you need to get information out of your function and back into your program, like input. Input is a function that returns whatever the user typed, right? We all use input. This means yes. That means you're confused. So,
Oh, I use it.
yeah,
I would just.
he's
Right, so I was
being
being a comedian.
It's okay. That's fine. Keeps me awake. So if you do this and you like this one's accumulating a value. Well, we probably need to use that value for something, right? So we need to return it to the program where the step that called it now has a value. To do that, we have to use a line of code at the bottom that starts off with the keyword return, and whatever is on that line, that value is going to be returned back to the program at the spot where it called the function. If you did it correctly and you set it equal to a variable, it'll store it. If you did not set it equal to a variable, it's going to return it, but it's going to disappear into the memory.
Unusable.
Yeah, it's going to end up in the memory garbage collection pile. And it did it, but you didn't ever see it because it's gone. So just like when you do an input statement, if you need compute average to return something, then you should put average equals compute average. Does that make sense? We're going to do some examples of this. Don't worry.
Like, first three, like, when we're done with this, will we be going over that today?
No, we are going to do this today, tomorrow in workshop. I am going to do lab 4, like I would in normal class day. I will record it. So you can either come and do it with me, or you can watch the recording. It's up to you. If you have questions about quizzes or assignments that have already been turned in, you need to email me instead of the time for us to talk about it. Or if I have some free time Friday, I'll be happy to answer questions. So these are snippets of code. I'm gonna see if my handy dandy pen will work today. Sometimes it does, sometimes it doesn't. So up here, we have defined a function called get distance moved. It takes 2 parameters. It's got size and steps, right? And then it's going to return the answer to size times steps. That makes sense? Pretty simple, pretty straightforward. So in snippet A, result equals get distance moved. And this time we're going to put in 10 for the size, and we'll put in 5 for the steps, right? So based on what I know about writing code, it should return 50, right? Yes. Because if I put 10 here and 5 here, 10 times 5 is 50, and that's what it's going to return. So now result is equal to 50, so this is 50. We're going to print total distance. It's going to print the number inside of result, right? I got a few nodding heads. Okay. In B, we have A is equal to 12, B is equal to 3, value is equal to this distance A, which is 12, and B times 3. Can I do that? Can I do math inside my parameter list?
No.
It was floating.
Yes, you can. So if you see this happen, it's going to go 3 times 3. It'll do that math first, pass in the total to your functions. So it's going to pass in 9. So the total distance value is going to be 12 times 9. Somebody do math. Huh? That's 9 times 9.
Wait,
108.
108.
Yeah, I was sleeping.
No, it's fine, it's fine. You're good,
You
man.
just scrambled the numbers.
Good try. That's why I make you guys do the math, where I don't make those silly mistakes at 8 a.m. in the morning. So does that make sense? Does writing on the board help out with the flow, following the flow? All right, so let's do a few more. Given the following methods, header and body, get distance moved, same thing. It's the same function, right? We're still doing steps times size. Snippet C, get distance moved, 12.5, and then 5 with quotation marks around it. What's the result?
One's a float, one's a string.
Absolutely. So what happens?
And
Yeah.
so,
You have to convert this string to float.
You would have to convert it before you put it in, but the way it's written right now, you're getting an error message, so your types don't match. right?
Yes.
So this is actually not gonna work. This is an error. Right? I did that on purpose. I wanted you to see that. All right, this one, x is equal to 10. So 3.5 and 10 times 3, which is 30, absolutely will work because it's still numbers. You're doing math on numbers, right? I'm not doing that math in my head. Huh? 105. I'm trusting you. I usually have a math major in my class that does all this for me.
Or calculator.
Yeah, or somebody pulls out a calculator. Input or snippet D, the input's 42. Now I have input and input. Can I do that? Absolutely. Let's just go put 42 and 42. And 42 squared is a number that I don't even want to do in my head. And so I have a calculator out and want to do it. It's fine.
1742.
1742. Ugh. Sure.
Yeah.
Okay.
Who cares?
Nobody really cares, but it will work. Yeah, that's what I thought.
So you can't do the math in your head.
No, I just did it yesterday with my class and knew that it didn't end in a 2. And 2 times 2 never gonna give you 2. All right, close enough. All right, does this make sense? Does that help?
It does.
So we'll try to do this more often. I just got lucky this week. Pins worked.
Because I remember last time it was like missing.
Yeah, every time I used it before, it just worked
Changed
like
the
a
screen.
mouse and changed the screen. So, like I said, the order definitely matters. The function must be defined before you call it, right? Importing a module imports all of its functions. So that's the reason when we import Turtle, we put it at the very top of the screen. That way all those functions get imported before we ever use them. Now, variables inside of a function are local variables. That means they only belong to the function. Like remember the for loop, we had I in range of, the I didn't exist outside of the for loop. Same with these parameters and any variable you create inside the function. They only exist while the function's running. So I caution you not to use the same variable names as you do your parameter names because it causes confusion. The program will absolutely let you do it because they're different scopes. So scope tells me what level or what range a variable has. So in the code we've been doing, because they're just in the main line of the code, those are what we call global variables that exist for the entire program. The I in the range of whatever for our function, the I scope is the for loop. It only exists inside the function. The functions are the same way. The parameters, those variables only exist for that function. Could I use size again somewhere in my program? Absolutely. And it would be a different variable with a different scope if it's used outside of it. This is why I tell you to be very careful naming your variables, because if you use ABC for all your variables, if you use ABC inside your functions, you're going to get confused which A belongs to what. Does that make sense? So here's a prime example of confusing yourself, right? So the function has an A and a B. And that works beautifully in the function. But if you get down here, and now I have a global variable of A and a global variable B. This B is not the same as this B.
Could that be up there? It will be like, basically. Oh shit. Okay, so A equals A plus 2. So basically, if A was 6,
So
the 4 plus 2.
before
that would
you
be 6,
before you
and then-
confuse yourself,
Yeah.
I love the fact that you're thinking, but before you confuse yourself, this is the definition. So all it is placeholders right now. There's no actual values in this definition. They're just placeholders for values. A hasn't been assigned a value in this place. B is going to be assigned a value after this function creates it. It's using 4 for the second parameter. But B outside of that loop does not have a value of 4. This is really confusing, and I know it. Which is why I'm telling you.
So I have a question.
So if you had B here, right? Then A and B both have a global A and B have values. And we're going to change the global B to whatever this is. But we're not going to put that 0 in to replace the 4 because it's not the same B. Does that not still? Okay. So suffice it to say, be careful naming your variables. Make sure that your global variables or your variables in the outer functions are different from the variables in the inner functions. Because you can have functions inside of functions. And you have loops inside of loops. And you can have loops inside of functions. So this is all going to start nesting together. Like those Russian nesting dolls, you'll have the little one inside the next one. So. It'll get clearer as we go, and I'll explain it again if I need to. All right, there is a special function that we are going to be using from here on out called the main. The main function is the primary driver of your program. It's what starts your program. It gets everything going. It's where you're going to call your other functions that you define in your file. It's going to keep everything organized and pretty and going. The call to your main, we're going to define main. And then the very last line of your file that you turn into main will call the main. Or make the program execute. It's really easy to forget that last line, and then you go press run, and you're like, it didn't do anything. It did. It just didn't show it to you because you didn't execute the program. So we're going to do that from here on out. I'm going to skip that one with a lot of math in it. So if I wanted to write a function called draw rectangle, I absolutely can, right? It'll allow you to pass in a turtle, a length, and a width. So if I was doing this myself, I'd go, I'm going to need 1, 2, 3 parameters because it says pass in. Pass in means that it needs information, right? So those are going to be my 3 parameters. And then I need it to draw a rectangle. Right? We know how to draw a rectangle. We can do it 2 ways. We can do it in a loop, or we can do it with lines of code. So I would start this off with D, E, F. I can't write today. Let's try to do it. D, E, F. Draw. I need a turtle. I need a length. I need a width. Don't forget the colons at the end. Right? So that would be my function header or my function definition for this example, right? I used my keyword def, I gave it a name, and I listed the parameters I needed. Now I need one or two things at this point. I can start a for loop. Really hard to write legibly with this. And then I'd have a line of code. Yeah, the line of code in here to draw the top on one side, and then I could repeat it and do the bottom of the other side, right? If it was a square, I do it in a range of 4, and draw the side would do the same. Does that make sense? These would be turtle. The lines I didn't write would be turtle functions. Now, you might be thinking, who's on this? I'm just thinking for the lines.
Yeah.
So I passed in turtle, just the generic word turtle. So when I get down here, I could do something like turtle forward length. I don't know. Pick one. Whichever one I'm doing first. So my turtle, when I create it, could be called Alex, Bob, Joe, Bozo the Clown, whatever. But everywhere the generic word turtle is, it'll replace it with my turtle once I pass it in. Everywhere I need the length, it's going to put that value in with the word length. Same for width. Does that make sense? Okay. So it makes it very generic and very reusable. I can have a rectangle any length and width I want. I can have any turtle I create use that function. I can have multiple turtles in my program, and based on which name I pass it, that one will draw a rectangle. You see where what we're building to here? That's what your first project is. You're going to be drawing with a bunch of turtles, or you're going to be drawing a bunch of things with turtles. I think it only requires 2 turtles, but you're going to be drawing with turtles. You're going to be using loops. You're going to be using functions. You're going to be repeating things. You're going to be calling me not nice names while you're frustrated. But it'll be all right. So another example, you could have draw figure like we did on the slide earlier, where it actually is going to pull other functions together. The draw figure will create the screen of the turtle. So you could actually create a function that builds your turtle on the screen. Because we always had to do that, right? And then inside the main, we can call that function instead of writing the code every time we want to create a turtle on the screen. You can modify your functions once you get them written and they're not quite right. Refactor them, modify them, change them, make them more useful. Draw rectangle is great, but I also need draw box. Well, maybe I copy and paste it, make changes where I have a draw box and I have a draw rectangle. You also could decide, oh, maybe I need to tell it where to start drawing that. So you could give it an X and Y value and stuff too. There's all sorts of possibilities. And that's, to me, the most creative thing about computer science is the possibilities are unlimited, what you can do with it. Where else can you recreate real life situations in your computer? Where else can you, simulate all sorts of things going on in your life or in your imagination for that matter? This is my artistic palette. I have no artistic skills whatsoever. As you can see me drawing on the board, you know this, but I get to be creative inside of computer science. All right, that's all I have for today. We are going to talk about some documentation and some more function, design principles. Next week, so ignore the exam 2 thing. We're gonna do a project first. Or I'll throw the exam in there sometime during the week that we're working on the project, but you'll get some notice. Questions for me? Yes, ma'am.
Yeah, we now start working on like the PSG stuff. Like, we don't have to leave, right?
You don't have to leave right this second now.